The following presentation is from Space Day, New York, May 25th, 2023, and is given by NASA Solar System Ambassador Robin Vernuccio. The topic is space telescopes, specifically the James Webb Telescope, exoplanets, and is intended for students aged 6 to 11. Empire Space hopes that you enjoyed the following presentation, find it informative and engaging. Please email info@empirespace.org to learn more.
Hello, everybody. Thank you for joining us for this Space Day New York event. This is a telescope STEAM event for kids, specifically aged kids 6 through 11, brought to us by NASA Solar System Ambassador Robin Vernuccio. We're very happy to have her on board with this segment of the Space Day festivities geared towards kids. Space Day is a chance to kind of celebrate New York's history in space and lay the groundwork for an exciting future. And one key component of that exciting future is the next generation, is young learners of today. We know how critically important it is to engage kids, especially when you're looking at building towards a career or something in space. It's best to engage when young. So that's why we're thrilled to have this event today. Without further ado, we are going to go ahead and turn it over to Robin. Just to let everyone know who's in the chat or who joins later, my materials list is posted up top.
Hi, everyone. I just want to respond to what Patrick just said, because I read somewhere that there were a ton of astronauts and people and astronomers that got interested in space science because they went to the planetarium when they were in 3rd grade. And when I was teaching 3rd grade, I always made sure all of my 3rd graders went to the planetarium to see space and get excited about it. So that's just a suggestion for you guys out there. So today's workshop has been inspired by the James Webb Space Telescope. And we're going to talk about a history of telescopes. We're going to talk about what the Webb's objectives are. And we're also going to talk about different things that have to do with just telescopes so people can understand how they work. Next slide. Okay, so telescopes versus robotic vehicles versus humans. So I want you to imagine, next slide, you're looking at the moon from Earth. It says, let's sketch the moon. We don't have to sketch the moon. But what I want you to do is look and see that the near side, the side that's always facing the Earth because of rotation and revolution, and we're not getting into that now, but you can look that up on Google. But we always have the near side facing the Earth. But look at the far side. It looks a lot different, right? You see a lot more craters. You don't see those sort of Maria blotches, those seas. So if we never sent man to orbit the moon, we would never know that the far side looks a whole lot different than the side that we're used to. Next slide. Okay, so the first spaceship to orbit, which means to go around the moon, was Apollo 8. And that was the first time we ever saw the back end of the moon, okay? And that was in December 1968, right around Christmas. And you might want to read up on the wonderful quote they made about seeing the Earth from space. Next slide. So here's the first picture of Earthrise, the Earth coming up, taken by the crew of Apollo 8. How long do you think it takes to get to the moon? I don't know how many people are out there that want to respond or if they just don't know. But when I ask it to children, I hear, oh, 7 months, a year, 2 years, 10 years. It only takes 3 days to get to the moon. The moon is pretty close compared to the other planetary bodies in our solar system. Next slide. So, as we go farther out in the solar system to the last planet, dwarf planet, whatever you want to call it, which is Pluto, because when New Horizons, the spacecraft, launched to Pluto, Pluto was still considered a planet. And now it's up for discussion. And we're not doing that discussion here, but if you're a teacher, that's a really good thing for the kids to read up on, and there's some pretty good books out there about it. So when Pluto launched, when New Horizons, the spacecraft launched to go to Pluto, it took almost 10 years. But now we've been there. We know what it looks like. So, so, so exciting. But if we have a space telescope, a really, really good space telescope, like the Hubble and like the new James Webb Space Telescope, we can see farther and farther out than we've ever seen before. Next slide. So, what's a telescope? Most people know a telescope is something that lets you see far away things close up. Next. So, we just did that. Next. Okay, so a telescope, and I'll show you this teeny tiny one I bought just so I could have it on the screen. Okay, so here's my teeny tiny telescope. Okay, but a telescope has two lenses. The first lens is known as the objective, and that's the one here. And then there's the eyepiece that our eyes look through. Okay, now there's two types of telescopes. Next slide. Okay, so first telescope we're going to discuss is a refracting telescope. And I want to show you, I'm going to push this out a little and put the screen down so you can see what I'm doing. But if we take this straw and we put it in a cup of water, I don't know if you're close enough to see, but you will see the bottom and then the top, they don't look like one straight line. The top part looks like it's moved a little bit, and that's called refracting. We understand the workings of a refracting telescope with a glass of water, and also you can have some print material that focuses on the light. So look through your glass of water and you can see the writing. You can't really see it too well on the screen, but the writing gets bigger as you look through the water. That's why when you go to the restaurant and you forget your glasses, you can actually look at your glass of water and look through it at the menu and see it a little better. I've done it, it works. Okay, so magnifying glasses focus the light the same way, and you see how things get bigger through the magnifying glass. See how I pull it away and it looks bigger, the writing on the page, okay? And that's something called refraction. And telescopes do that to help us see things that are far away. Next slide. The other type of telescope is a reflecting telescope. And I want you to remember, you can be home, you can go and look in your mirror and you see yourself, okay? It uses a mirror, the reflecting telescope uses a mirror, and the image bounces off the mirror so you can see me here on the screen going right back at you, okay? The light bounces off the mirror, and so you can see me from the screen, and that's called reflection. And look at yourself in a mirror. If you have a small mirror, you can see your face because that's reflection. Next screen. Now, space telescopes, okay, they see really, really, really far out. And so we can ask, how many space telescopes have there been out there? What is a space telescope? Is it only NASA that has space telescopes? So right now there are space agencies like NASA, our NASA, like the Canadian Space Agency and the European Space Agency that can combine their resources to build these large telescopes and then have the money to launch them because it costs quite a bit of money to launch through the atmosphere. So they can go into space where it's not as distorted as like looking through our atmosphere around Earth. So the James Webb Space Telescope's not the first giant telescope, and I'm going to give you a little short history of some of them. Next slide. So here's the Hubble Space Telescope. That was the telescope right before the Webb Space Telescope. It went into Earth orbit in April 1990. It's still working to this day. Later on in the presentation, we're going to look at the difference between the development of Hubble and the Webb Space Telescope, because the images are unbelievably clearer as we advance our technology. Next slide. So there was the Spitzer Space Telescope launched in 2003, and it operated for 17 years. Next slide. There was the Kepler Space Telescope that was launched in 2009 and operated for 10 years until NASA announced that the telescope had run out of fuel and they were shutting it down. And Kepler was known as the original planet hunter. It was sent up specifically to search out and see, are there planets out there beyond our solar system? Next slide. So the James Webb Space Telescope was launched on an Ariane 5 rocket. It was Christmas Day. It was really early in the morning. I was in my pajamas, sitting on my bed with my legs crossed, watching it launch from Kourou, French Guiana. And it had 3 launch partners working together to offset the cost and offset the technology, combine the technology that these different places had to make this a great space telescope. They were the Canadian Space Agency, the European Space Agency, and of course, NASA. It was not regarded as a replacement for the Hubble that we just discussed, but it was launched to enhance the pictures that they could get because it was further on in technology. Next. Okay, so the James Webb Space Telescope headed out of Earth's orbit to a place called Lagrange 2, okay? It's a place where the telescope could orbit the Earth but not fall out of orbit, okay? And it's almost 1 million miles beyond the Earth. And it's an area where the gravity from the sun's pull and the Earth's pull sort of even each other out. And because of that evening out of pull, it can remain in orbit, okay, without having to expend energy to stay there. Next. Okay, so today we're specifically talking about the Webb Space Telescope, which is our newest wonderful, wonderful telescope, and the different objectives it had and what it's discovered in its very first year. Next. Okay, so it's unique. It's the size of a 3-story building and has 5-layer sun shield, the thing in the front that keeps it from overheating. That sun shield is the size of a tennis court. So already in your mind, oh my God, it's so, so big. The side that's facing the sun will get temperatures as high as 260 degrees Fahrenheit. Quite high, since when it's 90 degrees, the way it was in New York last week, we were all hot, okay? But the other side, the one that's not facing the sun, it has a temperature of minus 370 degrees, and all of this is in Fahrenheit, guys. So there's nearly a 600-degree difference. It has an SPF, you know, when people are buying sunscreen to protect the UV rays from hurting our skin. And we can buy 15, we can buy 32, we can buy 50, we can buy 100. Well, if you were going to put SPF on the Hubble Space Telescope, I'm sorry, on the James Webb Space Telescope, you would need an SPF, sun protection factor, of a million. Ay, 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 big numbers. Next. So it's the largest telescope ever to launch into space. How do you suppose something this big could be launched into space? The size of a tennis court part of it? That's ridiculous. So what they figured out is that they could fold up these mirrors, these golden parts, okay, and put them into a spacecraft. There's 18 of those mirrors, and they could launch the mirrors all folded up, because folded up, imagine folding up a letter instead of having the regular size letter. If you fold it up, you can make it really small. What a great idea for the space community. Next. So here is the folding sequence, and it's online. ESA published it. You can look it up, and you can see how, as you look at these pictures, it was folded up and then it unfolded once it reached its orbit at L2. Next. So let's learn more about these mirrors, okay? Because remember, the Hubble had trouble with its mirrors and they had to send a space flight up to fix them. But Webb's telescope is so far out, we had to get it right the first time. So there are 18 of these mirrors, these hexagonal mirrors, okay? And deploying it was like an origami project in space. And if your kiddies are out there, some of them know origami, some of them don't. My grandson adores origami. So how could I not introduce origami when that's the same idea that was used in the space telescope? Next. So we're going to try making something out of origami. I searched for a really easy, simple project. If this is your very first origami, grown-ups can do this too. You're never too old. And so what I'm asking for is you either have a 6x6 piece of folding origami paper you can buy in the craft store. Okay, and it comes in different colors or solids or whatever you're interested in. There's also 8x8, which is bigger. If you don't have one of these, you just take yourself a piece of copy paper from the computer and use a ruler to measure 6x6. So here's your ruler, and you make a 6x6 piece of paper. I already have it 6x6, so I don't have to do that. But follow along. So I'm going to put the thing down so you can see the table. And what we're doing is we're taking the colored side and we're folding it in half. So we get a triangle. Next, we're going to fold it in half again. So we get a tinier triangle. This is such an easy project, so don't be scared off. And then we're going to open it, okay? So here we are, open. There's a fold in the middle, and it's folded in half as a triangle. I'm going to have you take your triangle from the middle, this part, and just fold over an angled piece like that on one side. Okay? And then we're going to do, of course, the same thing on the other side. And we're almost there, guys. Don't be upset. You're getting there. This is so wonderful. We're going to take it and turn it over. Now I'm going to take the top and just fold a teeny tiny little triangle. You see, a little triangle at the tip top. And that's going to be our doggy's head. And then what we're going to do is we're going to fold the chin up. So we have these two folds. We have a fold at the top and a fold at the bottom. And when we turn it over, we have the beginnings of our dog. And now all we need is a marker or a crayon or whatever you have that works. And we're going to make our dog's face, his little nose, go down and make his mouth. And there we have our first origami project. And if you really like origami, there's plenty of books out there. And there's also tutorials online and YouTubes about making origami. And who knows, you might start with this little pup and end up making your own space telescope that folds gigantic mirrors yourself. So this is our first project. Very kid-friendly. And you know what, grown-ups? Friendly for you too. Okay, next slide. Project number 1 is done. We're going to do a new science experiment, and this is on light. Next. Okay, so we're going to be working with prisms. And my prism seems to have disappeared, but there are many other prisms out there. This is a prism. I work in a historic house, and all of these little things hang from the light fixtures and hang from the candles because they reflect light. Another thing would be this great big object. Again, if you hold these objects up to the light in your living room or kitchen or wherever you're at, you will see a little rainbow there, okay? And that is because light is being pulled apart, and white light in a prism can be used to separate the light into the colors of the rainbow. And if you're past first grade, I think you will hear the expression Roy G. Biv, the colors of the rainbow in order. And there they are right there through the picture: red, orange, yellow, green, blue, indigo, which is a blue violet, and violet or purple. Okay, so we're going to try to create, oh, and also even easier, got a CD, got a DVD. You notice the rainbows in there. You can even see it right there on the screen. So you have a way of making a rainbow so easy in your house. But I'm going to give you another way of making a rainbow. Next slide. So we need a piece of paper, copy paper, put it down on the table, and we need a cup of water, just a clear cup and water from the tap. What could be easier? What you do in order to make your rainbow this way is you take a flashlight. Now, I found when I went to Dollar Tree, Teacher Source, right? A lot of the flashlights had a yellow tinge to them. I don't know why, but I found one that didn't have a yellow tinge. And as you put your flashlight and angle it on your water over, oh, you can't see it there. Let's see if I can get it in the front. You can get the colors of the rainbow just by splitting the light through the water. So try this at home. I don't have the patience to sort of angle it now so you can see it on the screen, but it works. It does work. I've tried it many times. So that's experiment number 2. We've created a rainbow. You see the rainbow there at the bottom of the screen, at the bottom of the slide, the middle of the slide, the bottom of the glass. You can create your own rainbow, but frankly, I like this way. You got your rainbow coming out of your DVD or your CD. And the reason is because there's all these refraction lines going on. And that's what's causing the light to split apart into the colors of the rainbow. And there's nothing that kids love more than rainbows. Next slide. So the colors of the rainbow are known as the color spectrum. As I said, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. And the indigo violet is purple changing into blue. But the reason we're talking about the spectrum is because the Webb Space Telescope uses a certain type of light to see, okay? So one of the projects you can do if you work with kids, or if you are a kid, is to go out to the dollar store or Walmart or wherever you can get your beads and get beads that are the color of the rainbow. Now, on both sides of the spectrum, you will see there's infrared light and there's ultraviolet light, and I'll explain that in a minute. But right now, I want to show you, you can take all these beads and place them on a piece of paper and do your Roy G and then Biv here. Now before the red is something called infrared, and that will add this infrared bead for the front here. No, we're going to use the black as the infrared. And then after the purple is the ultraviolet. Blue, indigo, violet. Okay. Now, ultraviolet lights are kind of cool because they change when you go out in the sun. They will change color. And this is an ultraviolet flashlight, but it's not really giving you what's going on. You can't really see it online. But if you go to a store that has the ultraviolet beads and you make a bracelet of these beads in the sun, you will see them change color. Most of them sell, they turn purple, but I wanted one that changed yellow, so that's what I bought. Now, in order to make a bracelet of this, you can get yourself, you don't have to get the string and tie the knot. No, much easier. You get a pipe cleaner and you start stringing the beads the way you line them up, Roy G. Biv, on the piece of paper. And that way, if you forget Roy G. Biv, you can always look down at your bracelet and tell what's going on. So here I am stringing the beads along. Violet and the ultraviolet. And when you go out in the sunshine, the sun will change the ultraviolet into whatever special color. These beads are cheap. They're like $3, $5. And you can actually get something like this at Dollar Tree, only I didn't like the color. There was no reds and it was only pink, so I didn't buy it. So that's why I got that one. But once you got your bracelet, make it bigger so you can slip it on and off, and you can make yourself a nice little bracelet like this. I have one that's already tied. You slip it on, you check it out, you slip it right off. So it's a way of remembering Roy G. Biv. There it is. Okay, next slide. Okay, so the James Webb, I told you we discuss infrared and ultraviolet. So the James Webb Telescope is using infrared light, okay, the light that comes before the red. So we're using ultraviolet light, that's the light before the red light, the Webb Space Telescope, in order to look far out into the early universe to see distant galaxies. And it allows the telescope to see through the gas and dust of space to see far off planets beyond our solar system. And if you look, the Webb Space Telescope is going to try to capture, and it's done pretty close to this, things as old as 13.5 billion years, which is supposed to be the age when the Big Bang occurred. So next slide. Even older than stuff that the Hubble has seen. More on exoplanets. Okay, so an exoplanet is a planet that's out there beyond our solar system. Why is it important to know? Well, we can think of the origins of Earth. We can think of, is there somebody else out there? All kinds of fascinating things by looking at other planets way beyond ours and looking at their atmospheres and their landforms. Next. So, the Webb Space Telescope, one of its objectives is to search for exoplanet. So it says here, an exoplanet is a planet that orbits a star outside of our solar system. The first exoplanet was not seen until 1992. So that's like 21 years ago. Okay? No, that's 30 odd years ago. Math is not working for me today. Okay, so NASA just recently announced the discovery of the 5,000th exoplanet, and even thinks there could be billions of exoplanets outside our solar system and our galaxy. Exoplanets are common. There are 1 to 3 planets per star, exoplanets orbiting stars. It's more common to have a star that has exoplanets going around it than not. And scientists have discovered that smaller exoplanets are more common than bigger ones. And all we have to do is sort of look at our solar system and find that when we thought of Pluto as a planet, there was Pluto, there was Mercury, Venus, Earth, and there are 4 gas giants. So I left somebody out. Mercury, Venus, Earth, and Mars, and Pluto. Those would be the rocky planets. So there would be 5 as compared to 4 gaseous planets, Saturn, Jupiter, Uranus, and Neptune. Next slide. So how do we search for exoplanets? How do you think the Webb Space Telescope is going to search for these exoplanets? So this is another one of those things that you have to get through your head because it just, wow, it's beyond understanding. The Webb Space Telescope is so powerful that it could see details as small as a penny, and we all know how big a penny is, but they could see the details of the penny 25 miles away. Wow. That's like in New York City. So 1 block is like 20 blocks is like 1 mile. So it would be 20 like times 25 blocks. Long way away. Next. Okay, so one of the exoplanet systems that we're so excited about is something called TRAPPIST-1. It's a planetary system. It has a bunch of planets that revolve around a star in the constellation Aquarius. And NASA announced its discovery in February 2017, and it has 7 Earth-sized rocky planets orbiting a red dwarf star. And the question here is, are any of these rocky planets suitable to have developed some kind of life? Doesn't have to be human life, just life in general. That's what we wonder every day. Next. Okay, so I want you to think of a planet, okay? And I want you to think of our solar system. So think of the Earth in the middle of our solar system, okay? Not the middle, but in the middle of this habitable zone I'm going to talk about. If we think of the 2 planets that are on each side of the Earth, my very excellent mother just served us pistachio nuts, or depending on, or just nuts and no pistachios, or I'm talking about, see, the thing with Pluto, the problem they had with Pluto is it doesn't remain in its orbit. Sometimes it crosses the orbit of Neptune, which is one of the things that had it disqualified as a regular planet and became a dwarf planet. But it's a whole big discussion, and it's teachers, good discussion to have in class. But we're going to go to very excellent mother, okay? Venus, Earth, and Mars. The habitable zone of a planet is a place where liquid water can exist, okay, because we need water to live. So if we think of Venus being closer to the sun than Earth, Venus, as we say in Goldilocks terms, is just too hot. If we think of Mars, there's a whole lot of stuff coming out, people talking about whether Mars has water underground or not. But for the most part, when we look at Mars and we look at pictures of its poles, it's ice there. So Mars is too cold. But right in the middle, what's the planet with liquid water? It's Earth, okay? So this is called the habitable zone or the Goldilocks zone. Not too hot, not too cold. That's right. Okay. Oh, good. Welcome. Welcome, Sadia. Next slide. So there's two ways the James Webb Space Telescope can use to find exoplanets orbiting these far-off stars. So if we have a light of the star in the middle in this picture, and maybe there is a planet orbiting that star, very, very sensitive scientific instruments can see that if you look at the under the circle, there's those lines, that when the planet passes in front of its star, the star dims very, very slightly. And that's called the transit method. And a lot of exoplanets have been discovered that way. Next slide. Another method is direct imaging, where you're looking at the star and you see something going on in front of it. So I want you to think of a car with the bright lights on. In order to see the car itself, you have to block out all the light, not the bright light that's in your eyes. So direct imaging of exoplanets works the same way, where you sort of have to block out the light of the star, and then you can see that maybe there are planets orbiting the star that could have been lost in the glare, the brightness of that star. So those are the two ways that James Webb Space Telescope is using to identify different planets, exoplanets that could be orbiting stars way out there. Next. So it's absolutely fantastic telescope. On February 11th, it snapped an alignment of a star backed by galaxies. And here's that picture. So this was the very first picture they released to the public. And if you look here, you see the star sort of has those lines that come out, you know. The difference between the Hubble and the Webb is if it has 6 little lines coming out when they take the picture, it doesn't really have those lines. It's just the way the image is caught. It's Webb. If it only has 4, it's Hubble, because Hubble is not as powerful. Next. So then we went into the deep field of the Webb Space Telescope, and I'm going to be showing you the first set of, I think it's 5 images that were released to the public. So the first image that was released is this deep field, okay, and it's a galaxy cluster. Notice the lines from the brightest part there has the 6 little lines, And it shows thousands of galaxies that are more than 13 billion years old. Okay, almost the beginning of our solar system, of our galaxy rather. Next slide. The second image was that of a gaseous exoplanet called WASP 96b. It's important because there's a steam cloud around this giant, okay? You have steam, you have the different elements that we make water with, okay? The planet is closer to its star than Mercury, so it's really, really, really close. But nonetheless, the atmosphere showed it had water. Whoa, water way out there in space. And I wrote, hey, Goldilocks. But it's not really habitable. It's so close to its star. Next picture. So this is the Southern Ring Nebula. It's 25,000 light years, 2,500 light years away, and it's a star that's dying. And the gas and the dust that you see in the images caught by the infrared are these images, and it shows gas and dust that are being let off by the star as it dies. Next image. Okay, this is the one I love. Stephan's quintet is a grouping of 5 galaxies that are held together by gravitational force. It was made by over 1,000 separate image files. It's 300 million light years away from Earth. And the way they look at it is they think that these galaxies are sort of combining. But I mean, imagine the size of how big our planet is. Then how big is our solar system? And our solar system's only a teeny, teeny part of our galaxy, okay? But these are 5 galaxies being caught in this picture. NASA can even tell the distances among these galaxies, with one side being nearer. And in the top galaxy, what's going on is they think there's a black hole. So just up to the date, fantastic, incredible science that's almost beyond your imagination. Next slide. Okay, so this is the best for last. This is Webb's final image. It blew me away. Look at it. Look how incredible. It's a picture of a star-forming region called NCGC 3324 in the Carina Nebula. And a nebula is where stars are being born, okay? So this is 74 light years away and is part of our Milky Way galaxy. But nothing else has ever been. Look how clear this picture is. Amazing. And again, you have those 6 lines coming out there. So this was the first bunch of images that were released from the Webb Space Telescope, but I promised you this year. There have been so many, 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 many pictures being released and comparisons to Hubble and everything. And I just want to show you some of them. And there was something incredible that was released 2 days ago, and I didn't catch that. But you might say recent picture by Hubble, by the Webb Space Telescope, rather. So next slide. So Bill Nelson, who is the director of NASA, ended the first image reveal with a quote from my hero, the famed scientist and astronomer, Carl Sagan. And it says, somewhere, something is waiting to be known. So all you people who are out there, especially the youngins, you can go into space science. You can work on things like the Webb Space Telescope. You can find all kinds of unimaginable things that just will blow other people's minds. And it's just waiting for you to go out there, learn your math, take your science courses, and you can be part of this. How cool to be young and to be able to go ahead in science. So now I have some more images I want to show you. Next. So the Webb Space Telescope has proven to be our new ticket to the understanding of the universe. And I promised you at the beginning that I would show you a comparison of Hubble versus the Webb Space Telescope. So look at the image that's without all those beautifully defined stars. The one on the right or your left, depending where you are. The image, that was something that was released by Hubble. Everybody was blown away by it, but now the Webb has taken that same area and focused on it, and look how much clearer, how much more defined, how many more stars there are there because we have a stronger, better telescope. Next. So that was the pillars of creation, that last picture. But here we look at some of the images, again, infrared. So the color, maybe the Mars color is really, really good because it's so close, but the colors of the other planets are kind of off because we're looking at them from infrared. So we have Mars as our first picture, Jupiter our second, and if you look at very, very closely at the picture, you can see the faint rings going around Jupiter. And then there's the fantastic rings of Saturn that have been in the news lately. And look how beautiful they are. And they're not solid, boys and girls. They're made up of rocks and dust, but they just look amazing. If we look at the picture on the left, that's Uranus, the next planet out from the sun, and again with a set of rings, and Neptune, which was only comparatively recently discovered to also have its own set of rings. Okay, so this is, Hubble is not only out there for exoplanets outside our solar system or in other galaxies, but also there to help us see better the stuff we know and love, our planets. Next slide. The James Webb Space Telescope viewed ancient stars and galaxies such as these stars, again, 13 billion years old from the beginning of our solar system. And notice again the 6 lines. Next, it viewed merging galaxies on the top and black holes. And the earliest black hole ever seen in the universe is in that bottom picture. Notice how the light is disappearing into that black hole. Amazing. These things just blow my mind. Okay, next. As you well know, exoplanets are an important part of the Webb explorations as we studied earlier, okay? And researchers have revealed how they have discovered the first exoplanet using the Webb Space Telescope itself. So it isn't something that we had previously seen before, but this is something brand new, discovered by the complexity and the greatness of the Webb Space Telescope. The planet, which is named LHS 475b, is about the same size as Earth, and it's a rocky planet. We're a rocky planet. It's only 41 light years away in the constellation Octans, and it was made last August, but it wasn't presented to the public until January 11th, and that's what it looks like in scientist pictures. Maybe drawings, I should say. Next, the artist concept represents the rocky planet JG 486, which orbits a red dwarf star, is only 26 light years away in the constellation Virgo. And the Webb Space Telescope, remember that picture we saw, the second picture that was released to the public, where they said they had the signature of water? Well, here, the Webb Space Telescope was able to observe water vapor around a distant rocky planet. If we have water vapor, okay, could be the beginnings of a Goldilocks zone, which is a habitable planet zone. In the short year of its operation, the James Webb Space Telescope has made so many astronomical discoveries. And I only gave you some of them because I tried to pick out really, really cool ones, because otherwise this presentation could just go on and on and on. I think that's the last slide. Stay tuned. And remember, we're going from this to space telescopes. It's amazing. Does anybody have any questions?
First, I want to say thank you very much, Robin, for that presentation. That was absolutely fantastic. It's a wonderful addition to the Space Day lineup to have something geared for kids. If people do have questions, feel free to leave them in the chat. I was hoping you could talk a little bit briefly just about being a NASA Solar System Ambassador, like how you got connected with that, what that program is, how people can learn more about that.
Okay, so I've been, I think I just looked it up. I think it's 11 years. I've been a Solar System Ambassador for 11 years. And what Solar System Ambassadors do is they go out to the public. I do a lot of youth groups. I've even done homeschool groups where this presentation was actually part of a homeschool group that I presented, where I go out into the community and I share my love of space and try to get people involved in what's going on in space, the latest discoveries. I also, online, I've been doing these readings with Robin where I will take space books and I will read them online so kids can like just tune in and learn about famous astronomers. My interest in space came from a book I read when I was between 8 and 10 years old. Who can remember back that far? But it was about a woman named Maria Mitchell. And Maria Mitchell is regarded as the first U.S. astronomer. And it was one of those books, Landmark. I don't know if you guys are familiar with that, but that was the big, it was like these books that were this thick, and they were all about different biographies of people. And I read about this Maria Mitchell, and I just was overwhelmed with the discoveries she made. And there's actually a new book called Maria's Comet, which I have read online. If you trace my Solar System Ambassadors, it's listed there. But Maria's Comet is all about the first comet discovered by her, but it's in picture book form. And I think there's a second picture book about her too. But she's who got me interested in space. Way back in my day, there was an astronomer, as Bill Nelson, the head of NASA, quoted, by the name of Carl Sagan. And Carl Sagan, he was on Johnny Carson, who like it was the equivalent of Jimmy Kimmel or whoever's on the air now. But he would go and he would talk about space. And then he had a show called Cosmos, which you can still get the book of. And it shared all kinds of wonderful things about space. And Carl Sagan also wrote a book called Contact. Are you familiar with Contact?
Oh, yeah, I've seen the movie a bunch of times.
Contact was then made into a movie, and it was all about our first encounter with an alien civilization. And I totally recommend reading anything by him. And he was married to a woman called Andrew Yen, and she also has written wonderful things. And Carl and Anne published this this disc that was attached to the Voyager, which went out through the solar system, and they called it Murmurs of the Heart, and it was all kinds of sounds from Earth. And then it had pictures of two Earthlings, and it told in pictures about where Earth was and our civilization. And it was sent out in Voyagers, which are now like heading out of our solar system, just in case they made some kind of contact with somebody out there. So just sparked my interest, and then NASA came up. I ran this thing called Young Astronauts, which was to get kids interested in space. And when that shut down, I got into solar system ambassadors because I think space is just such a wonderful thing, and it's got to be shared by people who are enthusiastic about it.
Well, thank you very much for this presentation. It's a resource that we hope to share around. We look forward to doing this again in the future. We will post all the links to your NASA Ambassador profile and how people can reach out to you below. So be sure to follow along for that. And thank you, everyone, for joining us.
Thanks, everybody. Thanks, Patrick. Thanks, Evan. Bye now.
Thank you very much for watching. We are incredibly grateful to Robin Vernuccio for her presentation. Stay tuned for future STEAM opportunities from Empire Space. If you have questions, comments, are curious about this video, please email us at info@empirespace.org. Follow us on Twitter at EmpireSpaceNY. Learn more about Empire Space at empirespace.org. Again, thank you very much for tuning in. Be well.